Dun-dun-dun, dun-dun-dun. Welcome to the Chemistry Lab halftime report of the amino acids versus the Butler Biochem team. And I'm Rhonda Burgundy.
I'm Veronica Corningstone, and here in the first half, we've seen a lot of denaturation, misfolding, and most importantly, attacks on the N-terminus.
And now into look into the BBB locker room with Coach Johnson.
Oh my gosh, guys.
I'm so angry! Gosh, those amino acids are tough.
Yeah, we literally couldn't do anything. That was miserable.
What in the world is that out there? God, I thought you guys better than that.
But Coach, can I explain?
No, don't talk. I've taught you better than that.
There's nothing we could have done out there, Coach Johnson.
Yeah, that was pretty obvious.
We were trying to build our peptide, but I dislocated my knee.
But, we couldn't even protect our first amino acid without it being blindsided on its N-terminus.
Coach, didn't you say we could put the amino acids in one by one and they just fit together?
Peptide synthesis is a game of steps. A simple game, but it has to be done the right way.
So, what's the plan, Coach?
Think PCDFR. So, P, C, D, F, R. The first step, P, is protecting the amino acids. The second step, C, is coupling C-terminus with a stabilizing group. The third step, D, is deblocking the main group. The fourth step, F, is forming the peptides through AA coupling. The fifth step, R, is releasing from solid support.
How are we even going to remember that many steps?
It's easy, as people collect donkeys for riding.
Oh, that's an easy way to remember it. But what does it mean?
The first step is to protect the amino acids. And the way we do this is usually through a carbamate group, as shown up here. The one that we are going to use is FMOC. And FMOC attaches to the N-terminus side through this reaction. And that's how we protect our amino acids.
Coach, why do we even need to protect the N-terminus? Why is this important?
Do you want your amino acid to get blindsided by its own kind? If you left this group, let's say it's glycine, without an FMOC protecting group on it, this glycine C-terminus would attack its N-terminus, C-terminus to N-terminus, C-terminus to N-terminus, creating a long chain of glycines. Now, what would you do with that?
So are you saying by protecting the N-terminus of our first amino acid, we can have selectivity?
Exactly. So who wants to try and tell me about coupling?
I can give it a try.
So look at this play up here and tell me what you think we're doing.
That's a steering derivative, correct?
Yes, that's correct.
So the C-terminus attaches to a steering derivative via an SN2 reaction creating an ester bond.
Exactly.
Since the steering derivative is so large it stabilizes the peptide, the repetitive chemistry of peptide synthesis is facilitated by attachment of the growing chain to a solid support.
So now we have an N-terminus protected by a carbamate and a stabilized C-terminus through a styrene derivative. What's next?
Oh, pick me!
Okay.
Well, with the use of a deblocking agent, carbamate protecting groups react with the anhydrous trifluoroacetic acid to liberate the amine, while the FMOC group, protecting group, is stable to most acids, and it can be removed with the treatment of a base to generate the free amino acids.
What's next in PCDFR?
Well, the formation of amino acids through amino acid coupling. Use the free N-terminus on the deblocked amino acid. The C-terminus on a new amino acid can attack that side and create a peptide chain with the help of a coupling agent such as TCC.
So like this? So the blocked amino acid can react with this C-terminus of this amino acid and create a bond like this? Is that what you're saying, Catherine?
Precisely.
So by the use of this DCC, we can create an intermediate that will help facilitate our peptide synthesis. Great, now we can repeat previous steps to make our peptide chain even longer and longer. So what's the final step?
Well, it's the release of the peptide chain from the solid support. An acid is used to remove the stearin to form the final product.
Good. Let's go over peptide synthesis again for all the steps in play. What's our chant, guys? Protect, couple, deblock, form, release.
Alright guys, let's go synthesize the peptide on the keyboard!
EFR on 3. 1, 2,